Okay, let's start the second part of the lecture with the basic idea of ANOVA. So the basic idea of ANOVA is the partition of the total variation into two parts. So there are variations within each sample, and there are also variation between sample means. Okay, so according to the huge table I showed you last time, each column is for a sample, right? So the variation within columns can also be considered as the variation within samples. Similarly, the variation between column means can be considered as the variation between sample means. And when we quantify these two types of variations, we will need to compare them. Compare the variation within columns to the variation between column means. So if the between variation is much greater than within variation, then we reject the null hypothesis. If the between variation is not very large relative to within variation, then we fail to reject the null hypothesis. What is the null hypothesis? The null hypothesis is that the population means for these samples are equal to each other. Okay, and how to quantify them? How to quantify within variation and the variation between sample means? So we use these formulas. The first one is for within variations. It's called WSS, within sum of squares. We use WSS to quantify the variation within samples. In order to calculate it, you have to finish this summation, okay? And of course, each term in this summation is representing a sample. So this summation is from the first sample, j is equal to 1, until j is equal to k, which means this summation includes all samples you have. All samples you have. Okay, so let me erase this. So in order to calculate WSS, you need two parameters. First, the number of observations in each sample. Second, standard deviation of each sample. Okay, NJ here is to represent the number of observations in a specific sample. J is the index for samples, right? And the standard deviation Sj is here to represent standard deviation of a specific sample. So on the other hand, between sum of squares, BSS, it is used to address the variation between sample means. So here again, we have NJ, which is the number of observations in a sample. X plus J, sorry, something wrong with my mouse. X plus J is here for what? For the mean of sample J. Or you can say it's the mean value of a sample. X plus plus is the overall mean of all samples. So we have WSS, we have BSS. If we add them up, it's the total sum of squares. It is used to address the total variation. Okay, so the total variation can be calculated as this, using this formula. So N here is the total number, overall number of all samples, of observations in all samples, sorry. N is the number of observations in all samples, overall value. And S is the overall standard deviation for all samples, okay? So we have BSS, WSS, TSS, and if you don't want to use this formula to calculate TSS, and you have BSS and WSS, you can simply add them up to have TSS, okay? Because that's the purpose. We separate TSS, and we use BSS and WSS to address TSS. You add them up, you have TSS, right? Okay, next, let's talk about F-test. statistical test for ANOVA. You can find another lookup table for F-test in your textbook. It's table 8.5. Okay, so the assumption for F-test is independence, normality, and equal population variance. They are consistent with assumptions I mentioned before for ANOVA, right? And here is the formula for F statistics. Okay, so it's a ratio. So we have numerator and denominator. So numerator is the ratio between BSS and K minus 1. And K minus 1 here is called degrees of freedom for numerator. And in table A5, the author used V1 to represent the degree of freedom for numerator. And it is calculated as K minus 1. K is what? K is the number of samples in your test, right? So denominator is the ratio between WSS and N minus K. So N minus K here is called the degrees of freedom for denominator, or V2 in table A5. So you are going to use K minus 1 and N minus K when you are looking up the table. Okay, so they are degrees of freedom. They are degrees of freedom. The calculation for BSS and WSS, I have introduced them in the last slide. I have also I've also shown them here, right? So the formula for BSS and the formula for WSS, okay? So as long as you have them, and you still need to calculate K minus 1 and N minus K, then you have a F-test value, okay? So just like other tests, t-test, z-test, when you have a specific test statistic, you also need to find out a critical value, right? So here for F-test, you need to know F alpha. Sorry, the alpha value for F-test, okay? It's still the old alpha you're familiar with, but you still need to know these 2 degrees of freedoms, K minus 1, N minus K, and you use lookup table A5 to find out the critical value. Okay, so you will, if you go to table A5, you'll see that it's a multiple page table. Each page is for a specific alpha value, which means as long as you have decided alpha value, you have to go to that specific page for F test. And then you use V1 and V2 to find a specific entry. And then that's your critical value. So the next step is similar to 2 sample tests and 1 sample test decision. You compare your test value with your critical value. Again, if your test value is smaller than your critical value, you are in the safe zone. You do not reject H0. If your F-test value is larger than your critical value, you have to reject the null hypothesis. Okay? Okay, that's the second part of this lecture. I will see you in the third part.